Molecular shapes. Molecular shapes. Valency shell electron pair repulsion model, VSEPR. This model determines the shapes of the molecule. We see between atoms, there is a valency electron pair. This valency electron pair try to repel each other and arrange as far as possible to minimize this repulsion. Valency electron pair means a pair of electrons on the outside shell. A pair of electrons on the outside shell of an atom. We go further. Electron, you can see there is a bond pair of electron and a non-bond pair electron. They both influence the shapes. Look onto water, H2O. H have 1 electron. O, group 6, have 6 electrons. So if you look onto these 6 electrons, how's all 6 electrons look like? They will have 2 pairs. These 2 pairs are the bond pair. They bonding with H. You also have 2 non-bonding pairs. These 2 pairs you also call lone pair. They are not bonding with anyone. Because oxygen have 6 electrons. Look onto the table. This pair, they don't need to bond with any atom, but they are by themselves. So that is called a non-bonding pair. So it comes totally, that is 4 pairs. And between pair and a pair, between the pair and the pair, they repel each other. This pair repel this pair to keep a maximum distance. This pair repel this pair to keep maximum distance. This pair repel this pair, and this pair repel this pair. And that's what it explains about this valency electron pair. They try to repel each other to arrange as far as possible to minimize repulsion. Now let's look onto the group 1, 2, and 3. H and F, 2 atom bonding. If this is only 2 atom bonding, it must be linear. 2 atoms, you can't form any shapes. Now let's look onto another. BE, F2. BE only have 2 electrons. And how many pairs are they? They're going to have 1 pair bonding, another pair bonding. So that's 2 pair electrons. And these 2 try to repel each other. Will be look like this. So each pair repelling and make it into a 100-degree linear. Further example, group 3. BF3. Look at where's B. B have 3 electrons onto the group 3. So how many pairs are they? They will have 1 pair bonding, 2 pair bonding, 3 pair bonding. And these 3 bonding pair, they try to repel each other. They try to repel each other to make a maximum distance. Will be look like this. Each pair repelling and make it into a triangular planar. So you can form into linear, 2 linear shape and a triangular planar shape because of this repulsion rule. We're going to examine further. Now we're going to look further onto the group 4, 5, and 6. Group 4, CH4. C have 4 bonds. So how many pair are they? They have 1 pair, 2 pair, 3 pair, 4 pair. In these 4 pair, each pair they try to repel each other. So now this forces into a tetrahedral shapes. Now let's look further. NH3, ammonia. Ammonia, be careful. It also is a 3D shapes, but you can see they have a lone pair, non-bonding pair. This pair, they still exert a repulsion. They will repel the other pair, so do not ignore. And so, what will be the shapes like? Of this repulsion will make it into a pyramid shapes, a pyramid, because you have 1 lone pair. Look at water, H2O. H2O have 2 lone pair and 2 bond pair. You have 2 lone pair, non-bonding, and you have 2 bonding pair. So what shape would it be? This pair, the lone pair will repel each other, as well as they will repelling the bond pair with the other bond pair. But the bond pair also repelling. And now this forces into a V shapes. So water have 2 lone pair and it is a V-shaped molecule. So they form into a tetrahedral shape, pyramid shapes, and a V shapes, all by this pair repulsion. How do we do double triple bond? Double triple bond, just treat as one region. I show you. CO2, they have double bond. So how's the repulsion? I don't care you double triple bond, I just treat you as one bond. So this is 180 degree. Another example. HCN. One is single bond, other triple bond. As I say, don't care how many bond, they just treat as one bond. 180 degree, linear. One more example. SO2. And you have a lone pair as well. So you force it into what shape? Into a banded V shapes.